Good day and welcome to Tech Tips and Fixes. My name's Ron. Today we're going to be looking at a damper pedal for an electric piano. So here is the pedal. It's a Roland DP10 damper pedal in a way. The pedal has a switch on the side of it, and that switch allows you to switch between two modes of operation. One says continuous and the other says switched. When it's switched, pressing the pedal will close contacts internally, and that sends a on-off signal to the keyboard. When it's in continuous, the pedal, as it's depressed, changes the position of a potentiometer, and that's used to change a voltage divider and change the voltage to the piano. And this pedal has a 1/4 inch TRS plug. These kinds of problems often have to do with cable or connectors. Sometimes these cables go intermittent, especially right at the plug, or where they go into the actual pedal. So we're going to open that up and take a look and see what we can find out along. The damper pedal is connected by a TRS plug, a stereo 1/4 inch with it, which that means tip, ring, and sleeve. And the first thing I want to do before I open this thing up is I want to just check to make sure whether or not there could be an intermittent in the cable itself, or where it connects into the pedal itself. So what I've decided to do in order to test this is I've just got a 1/4 inch jack here. Now this jack, when it's plugged in, these three contacts will be in contact with the tip, the ring, and the sleeve of the jack. I'll start by connecting to the sleeve and to the tip. And right now that is showing me 37 ohms. When I press the pedal down, it's going to open circuit, let it off, it's going back down to in the 30 ohm range. Now the pedal is in the switch position. I could switch it over to the other, but for now I just want to check the cable. So here I've got it showing around 29-30 ohms, and I'm going to try just wiggling and moving the cable, just see if I can get it to change in some way. And it seems pretty stable there. Often with a cable like this, if it is bad, it might tend to go bad right at a point where there's the most bending happening. So I'm not seeing any kind of intermittent when I do that. I think, okay, now I'm just going to try between the tip and the ring. That's showing 69 ohms right now. And as I say, I don't know for sure what those resistance readings should be as of yet, but we'll try it. I'm going to try the pedal, and when I push it down, it's going to an open circuit. When it comes back, it's going. Interesting. Now there's an interesting point there, because now it's showing 37 ohms where it was showing about 69 ohms. So something in here could be varying. And look at that. Now it's 20 ohms and it's moving around. So I'm beginning to suspect something inside, something to do with the switch. Maybe the switch is dirty, intermittent, whatever. So we've gathered some information that's worth pursuing. Okay, so we're going to open this thing up. These rubber panel here that folds out, this is just on here so that when you're using the pedal, your heel goes on that and it stops it from sliding away from you. So we'll take that off. We'll take off the screws and put them in my little tray so I don't lose them. Okay, so here's what we've got inside here. We've got the circuit board here. There's the switch for the continuous and switch positions on here. Down at the bottom there's a little switch. Appears to be a switch, and it's difficult to see the end of it, but it's against the bottom of the pedal, and when the pedal moves, it actually depresses the plunger on that switch. The other thing is that as the pedal moves, there's a cam here that is turning the shaft of a pot. The pot is right in here, actually on this side. So here is our little plunger switch, I guess you could say. It's a momentary. Here's the momentary switch. Here's the switch for, in this position, it's switching. In this position, it's continuous. Okay, let's just do another test here using the meter. So I'm still connected from tip to sleeve. I'm in the switched position. When I push the push button switch, it's again switching between 0 and open circuit. Now the very first test I made, we weren't getting that. We were getting something like 30 ohms across there. So I have a suspicion that just in opening it up and working this switch a few times, it's cleaned up that switch. Now that doesn't mean it won't go bad again. Also, a person should really just make sure again that there's no problem with the cable anywhere along the line. Sometimes you can have bad intermittence at the actual plug. I have on occasion come across a cable that was actually faulty halfway down, and that doesn't happen very often, but it does happen. So I'm not getting that. It seems to be operating correctly in the switch position. I'm going to take my cleaner and I'm going to spray that anyways and see if that we can just make sure that it stays good. This stuff, you get 90% of it all over the place. 10% of it in the switch, but when you get it in there, it does seem to help. So, by the way, what we're looking at here is this switch is operating in a normally closed momentary configuration. So we're looking at the normally closed contacts when it's at rest, and when you actuate it, that opens the contacts and we've got an open circuit. So that's how this switch is being used. Let's see what happens when we switch over to the continuous position on here. Now we're showing about 200 ohms with the pot in this position. Now this isn't necessarily the position that it'll be in once this mechanism is put back in there and is against the pedal, but we can see that as we turn it, we are changing the resistance. So it's showing when the cam is all the way to the left, we're showing about 200 and some ohm, 220 ohms. When we start turning the pot, it increases, and anyways, when you turn it as far as you can turn it, we get to about 10K. So it's probably a 10K pot. And there's really nothing else on this board. There's no, there are no active components or anything. All there is the pot on this one and the switch on this one, or the two switches on this one. So we're just switching between an on-off function and a potentiometer function. and that seems to be changing smoothly. When you see it jump to, oh well, that's because the ohm meter is changing ranges. See, we're in the kilo ohm range there now. The other thing about these pots is that they are not very easy to clean. They are pretty much sealed. Okay, I'm going to put this thing back together. Okay, so when I put this back together, what I'm finding is that the resistance that I'm measuring from tip to sleeve, it seems to be wandering a little bit, and I'm not sure how much of a problem that's going to be when you use it with a piano, but you can see there that it's got 453 ohms, and when I depress the pedal and then let it off, it comes back. It's in the 500 ohm, and it's varying around. As I said, these pots are very difficult to clean when they do need cleaning, because there really isn't an opening. About the only thing you can do is try to get some down in past the shaft. So I'm going to try that while it's still in here. We'll just see if we get any kind of response from this. See. So it took a while, but I was able to finally get some of that cleaner down into that pot. And in the end, we were able to get it so that when the pedal is depressed, it's showing about 10K, and when it's off, it's running somewhere in the 200 to 400 range. I think the variability has mainly to do with the mechanical aspect of it. So just to be sure, I took the pedal and I tried it with the Roland piano that I had available, and it worked identical to the pedal that was on there. And then I measured the other pedal, and it was running in the neighborhood of 250, 300 ohms at that low end. So here's the pedal all put back together, showing in that 200 range, and everything seems to be working fine. So I think that pretty much takes care of this one. Thanks for watching. I appreciate you tuning in, and if you'd like to make a comment, always happy to hear from you, and please like and subscribe, and we'll see you next time.